Okay, ma'am. Let me check.
Yeah, please check. Yeah. So today we are going to talk about the authentication protocol. And when you say the authentication protocol, the things are really different with respect to the way we are using it. Fine. So there are many authentication protocols depending on whether you would like to do the centralized authentication or whether you would like to do the distributed authentication. Now, when you take care about, so based on that, generally we move towards the distributed authentication where the authentication, server exists somewhere, and according to that, we are supposed to move on. Now, so every authentication, whenever we go with the client and server architecture, so every authentication is going to take care about authentication means, see, there are two things. One is identity. So when you say the identity, that means it's a username. So if someone asks you is the username is authentication, no. Username is an identity, nothing more than that. Username is just an identity. Now, when you say the username is identity, so how exactly the authentication is going to be performed? The authentication engine is your password, something you know. The authentication could be that something you have, that means could be your PAN card, or authentication could be something you are, that means your iris scan or the fingerprint scan or the retina scan, whichever the way biometric scan is supporting. So this is authentication. So when you take care about the distributed architecture altogether, and right now whether we are using the client server onto the centralized server architecture or the distributed, the authentication has to be done, right? So now when you say the authentication has to be done, so there are different kind of protocols when you say the authentication. One is the Kerberos. This is first authentication, and it was there, and it is really based on the symmetric key cryptography. When you say the symmetric key cryptography means what? The same key is going to be used for encrypt and decrypt the message. Please take a note. A same key can be used for encrypt or decrypt the message when you say the symmetric key cryptography. When you take care about the asymmetric key cryptography, so it is always going to be have the public and private. Generally, the public is supposed to decrypt the message and private is supposed to encrypt the message. Suppose I am a user, I would like to send the message to you. Public key is with each and everyone. Okay, so I am going to, if someone would like to send me a message, so someone is going to use the public key to encrypt the message, okay, to encrypt the message, and then because since I'm having the private key, so my private key can be used to decrypt that particular message. Are you getting what I'm trying to say? So this is asymmetric key cryptography. So we won't go right now with the asymmetric key. We will just take care about the Kerberos authentication. So there are many authentication protocols. So Kerberos is one. Saml is the second, security assertion markup language. Third is the OAuth or open authentication. And the fourth is the OpenID. All these are responsible to take care about the authentication where the distributed architecture is more and more. So we will talk about the SAML, OAuth and OpenID at the later stage. First we'll start with the Kerberos. As we have already discussed this particular thing, that there is going to be symmetric as well as asymmetric key cryptography. Symmetric key is going to be used in the Kerberos. It's a cryptography. So based on your credentials are going to be encrypted based on that particular algorithm, and according to that it is going to be shared. Sorry, it is going to be authenticated. Now when you say that it is going to be authenticated means what? So there must be some particular architecture which is supporting the the authentication mechanism of the Kerberos. So let me share my screen so that you will get to know the more and more design. Yeah. Yeah. So I hope my web browser is visible to you. So this is a Kerberos image what they have nicely given. Hello.
Yeah, ma'am.
Yeah. Now, how exactly it is going to work on? So here you can say it is a KDC. KDC stands for Key Distribution Center. The responsibility of the KDC is to generate the key. AS stands for the authentication server. TGS stands for ticket granting server. So the output is going to be the token. And this particular token is responsible to authenticate the authorize the user to to any of the service, you can say. So what exactly we need to have? You need to take care about the three different entities together. One is the AS, which is the authentication server. One is the KDC, and right now you can see that is nothing but the key distribution center. Third is the TGS, ticket granting service or ticket granting server, whatever you say. Now, the user alias is actually requesting the TGT from here. TGT means what? A ticket. Fine. Ticket granting ticket. We call it as a ticket granting ticket, which is nothing but the authentication ticket. Fine. Based on the request, this particular server is supposed to grant the ticket. Along with that, the session key. Now, just look at the user is requesting the TGT, but session is not being established yet. When the session is going to be established? By this particular session key, which is being given to this user. Are you with me, all the students? This is the session key, and this particular Kerberos server is supposed to give the session key along with the TGT to the user. Fine. So it is done. Now the third step is requesting the ticket along with the authentication. Fine. The client stores the TGT. So here it's going to have the TGT with it. Fine. And always it is going to, as soon as, because every ticket is going to have the some kind of what you can say, the expiration time. The ticket may get expire as soon as the session is getting established. So automatically a new ticket is going to be generated. Since now the session is being established, the new ticket is going to be generated with the authentication information. Again, it is going to send the ticket with the session key. Now here, initially the client was requesting the ticket only. But now, since the session is being established, now the request is for the authentication. Now, as soon as the authentication is done, the session key is being given to the alias user, and based on that particular session key, please take a note, based on that particular session key, on the fifth step, the alias is going to ask or going to use this particular ticket to authenticate on this particular resource server. And that's how the server is going to be or the request is going to be authenticated. Once again, I'm repeating the thing. Please focus on. This is a server, which is a KDC server. KDC server is a Kerberos distribution center, you can say, or Kerberos, what you can say, some says distribution center, but some says the database as well. It depends, but generally we use the distribution center, which is nothing but the combination of AS and TGS, which is the authentication server as well as the ticket granting server. And now this particular ticket is going to be in encrypted form using the symmetric key algorithm. So first is going to requesting the ticket. In the second step, it is going to requesting a ticket along with the session key. The session key is being given. Now the session can be established. Based on the session establishment, now this particular client again going to request a ticket for the authentication. Again, now the authentication is done. The ticket is being given with the session key. By using this particular ticket, now the LIS user can actually authenticate itself to access this particular resource server. And once the resource server is being authenticated, so LIS can actually access the service. So this particular ticket can be used anywhere as a single sign-on. It's a symmetric key cryptography. That means the same key can be used for encryption and decryption. Make sure about it. Then as many as users I am going to have, those many of the symmetric keys we need to generate. And if we are working with the global environment altogether, managing those many of keys are going to be a troublesome job. Second reason could be that how do I pass the symmetric key to the other user? Because the same key can be used to encrypt and decrypt. I have encrypted, but if someone would like to decrypt it, how do I do that? I need to pass that particular key to some other user. So that's what the decryption is. So this is the thing what I want when, so I do require a secure communication channel so that my keys can be transferred from one end to another end. And when you say the keys can be transferred to one end to another end, so what can we do? What can we do? So this is the thing. So wherever the distributed environment is, wherever the distributed cloud environment is, wherever you talk about the public cloud as well, the Kerberos Authentication Protocol is discouraged to use. Are you getting me what I mean to say, dear students? Hello?
Yes,
Are you with me? Are you with me right now? Everyone?
Yes,
we
ma'am.
are discussing the authentication.
Yes, ma'am.
Yeah. Now I'm giving you 4 to 5 minutes. Can you write it down? Please take a note. Write it down into your own words. The Kerberos method, by using this particular diagram, what I have shown you, the way the ticket is going to be generated. I'm giving you 4 to 5 minutes just to write it down, the explanation of this particular diagram.
Ma'am.
Yes?
Ma'am, why it is discouraged?
Why it is discouraged? The only why it is discouraged, the only thing is because I do require those many of symmetric key, and if the symmetric keys are getting passed over the public communication channel, anyone can hack it. Okay, so it cannot support more users. The scalability is less. Whereas right now with the global environment, we want more and more scalability. Fine. So that's why the asymmetric key is being supported.
Ma'am? Ma'am, so if the the data packets which are communicated between the channels publicly, if the keys are shared, then that means the data is not encrypted, right? It's not being encrypted.
It has to be encrypted.
Then how can someone hack? Like if it's encrypted and then the keys are
See. But in key is used to decrypt the data.
Yeah.
Are you getting me? When you say key,
The
when you say
private key.
symmetric or asymmetric key, so I am encrypting the data, but I do require the key to decrypt it. Fine, I cannot understand.
Yeah, got it. Yeah, got it.
So anyone can have that particular key to decrypt that data.
Okay.
Fine.
So it's
Whereas
kind
in
of a authentication, like a key or something, identification thing. Like anyone can take it and just
it's not
obtain the data.
identity, it's authentication. It's not identity, it's just the username.
Okay.
Yeah?
Okay, got it.
So please write it down into your own words so that we can move ahead.
Ma'am, this is for the symmetric cryptography, right?
Yes. So and Kerberos is an authentication protocol.
Yeah, got it. Thank you, ma'am.
Ma'am?
Yes.
Ma'am, so KDC, AS and TJS are the standalone parts of Kerberos. Can we say
Yes.
that?
Yes. And they are responsible to granting the ticket as well as creating the token.
Okay, ma'am. So they work individually
They work
for the
individually.
client.
Yes.
Okay, ma'am. Okay.
Are you able to write? Just let me know. Any difficulties?
Ma'am, I have a doubt again. Yeah. Ma'am, I'm getting confused very badly. What is the difference between the tokens and the tickets?
Nothing, no difference.
Both are same.
Yes.
Okay. Ma'am, previously you said that when a session gets created, for the every session we have a token. So ma'am, how can the like the token or the ticket get like it gets killed? How it gets terminated as soon as the new session starts? I
No,
mean, the
no,
session
no,
gets
Tanmay. Every ticket is going to have the validity period, fine? And
yeah.
after that, it is going to be expired. So the ticket, which is you can see into the second step, this particular ticket is supposed to generate the session.
Okay.
And once the session is being generated, then that particular ticket can be, what you can say, can be
Created.
renewed automatically.
Okay.
Right? And now the third step, the request is being given for the authentication.
Yeah.
Yeah. And
Yeah.
now the authentication ticket is getting generated along with the session key is being given that this particular user is being authenticated against this particular session.
Okay.
Fine.
Acha. Okay.
Yeah.
So that ticket is just for the creation of that session. So that is for that
Yes.
particular period of time. That's it.
Yes.
Yeah,
Yes.
got it. Got it. Thank you, ma'am.
Satvik, are you able to write?
Yes, ma'am.
Ma'am,
Yes.
ma'am, can you repeat the third step one more time? I'm a
Okay.
little bit
Yeah.
confusing on the step.
Fine. Yeah. So here in the second step, based on the request, the ticket is being generated for the session. Fine. Now the session is being established. After the session is being established, the ticket is going to be expired after some particular period of time. Now, that ticket is going to be automatically going to be renewed again. This particular user is going to the requesting a ticket for the authentication. For the authentication. Please take a note again, for the authentication. That means try to understand this particular thing, that with the user, the session key has to be embedded. Are you getting my point? All the participants. With the user, the session key is going to be embedded. So this is the session key and the TGT which is being given to the user. But right now this session key is not being embedded with the authentication. Now in the third step, this particular session key is going to be embedded with the authentication. That means it is getting requested. And now user is going to say, okay, the system is going to say, okay, this is the session for which the user is being authenticated. Are you getting my point? So somewhere the authentication of the user and the session key, they need to integrate with each other. So that's why step 2 and the step 4, these two steps are responsible for doing the same thing. Ahmad, are you with me?
Yes, ma'am, I'm with you.
Yeah.
So, ma'am, the whole process itself starts with the generation of the ticket.
Yes.
Okay, ma'am. Hello, ma'am.
Yes, please.
Ma'am, can I just say one, because I am writing the answer. If I'm wrong,
Sure.
can you just correct me?
Yeah, go ahead.
So ma'am, I just wrote like when the user requests, so that time the tickets get generated and so on, it gets created via session and all, right?
No, can you come again, please?
Ma'am, when the Kerberos protocol is initiated, like the user itself initiates the service or the request from the server, so that way the ticket gets generated, right? That's
Yeah,
the
upon
first step.
requesting only. Upon requesting only.
Okay, got it, ma'am.
Upon requesting
Yeah,
only.
right.
Yeah. Okay.
Okay, ma'am. Thank you.
Any questions? Shall we proceed right now? If you are able to write.
Yeah, ma'am. Yes.
Fine. All students, shall we proceed right now? Akash, Akshay, Del, Rohit, Satvik, Sutirtha,
Yes, ma'am.
Varun. Fine. So let me move. So just now we had a kind of discussion with Kerberos authentication, and you can see the different kind of images all together with the Kerberos authentication. Now let me have, so Kerberos is having this particular problem to have always the symmetric key. So because of that particular thing, we cannot move ahead with the scalability as well as the, you can say, the heterogeneity of the system. Now, if you would like to move with the more heterogeneous as well as more, what you can say, the scalable architecture. So there is a one more protocol which you can say the Saml. Fine. And Saml is a, the security assertion markup language. Please do take care about what I'm saying. So right now, this is a very nice image of the Saml. I do not think so this is readable right now. Let me open it up, the different image. Yeah. Fine. So just focus on what I'm saying. And Kerberos, as the Kerberos is also going to generate the ticket, and that particular ticket can be utilized by the user for the single sign-on. And with respect to that, we can have the multiple logins through that particular ticket. The only problem is the heterogeneity of the infrastructure as well as the environment. The next thing what I would like to have is a Saml, which is nothing but the security assertion markup language, and which is really going to help you out with respect to the what you can say is heterogeneity of the system. Right? Now, when you take care about the Saml transaction, so you need to understand two things over here. We talk about the heterogeneity. So heterogeneity could be the you can say the identity provider as well as the service provider. Right? So when you take care about the identity provider is responsible to authenticate the user. Right? Could be anything. Could be the Kerberos, could be you can say the LDAP, could be any of the Google Identity Provider server, could be anything. Now, and this is a service provider. So here, there's somewhere the user sits. User cannot access the identity provider directly. Here somewhere the user sits, and the user is going to start here. So user tries to reach the hosted Google application. Fine. So Google generate the Saml request.
Hello?
Hello, am I audible to you? Am I audible, everyone? Del, what happened?
Yes, ma'am.
Yeah. So Google generates the Saml request. Fine. After that, at the third step, Google redirects the browser to SSO URL. Now, SSO URL stands for single sign-on URL. So when you say
What is it again?
single sign-on, that means user is supposed to put the user credentials only for one time, not for many times. For each and every different kind of application, it's a single sign-on. Fine. So at the third step, so the third step means what? It's a service provider. Through the service provider, the request is being granted, the request is being forwarded to the SSO URL. And when the request is being forwarded to the SSO URL, that time you are going to take care about that, how exactly the request is going to be forwarded. So the request is going to be forwarded to the user browser, you can say, and the respective browser is going to redirect the SSO request to the identity provider. The respective browser is going to redirect the SSO URL, that means single sign-on URL, to the identity provider. Now, so this particular request is going to come into the Saml, security assertion markup language. This is nothing again but you can say it's an XML format. Fine. So just take care about this is nothing but the XML format. So Google redirects the browser to SSO URL, which is again being forwarded to this to the identity provider in the Saml. Saml is the XML format. Now, identity provider is supposed to, is my voice is breaking? Am I not clearly audible?
No, ma'am, you are
audible.
clearly audible. No problem.
Okay, fine. So in that case, it is going to, Dell, please check at your end. So what is going to happen? So here the Saml response. So identity is being cross-checked with the user, and it is going to generate the Saml response. And this particular response is being given to the user browser and then to the URL who has generated the request. Who has generated the request? Service provider. Who has generated the request? Service provider. And then the service provider will redirect the authentication accessibility to the user. Again, two things, please take a note. I'm going to show you how exactly the Saml looks like. Let me show that particular thing before move ahead.
Ma'am, can you just repeat once again what you just explained, like the identity provider thing?
Oh, hold on.
Okay, ma'am.
Okay. So let me show you the Saml authentication request. So these are the authentication protocols. So suppose you are going to go to the vulnerability assessment, you are going to work like the the vulnerability assessment person. So in that particular sense, you need to address this issue that how exactly the vulnerabilities are going to be addressed when you move towards the more and more distributed architecture. So let me cancel this. Just hold on. Yeah, so let me share my screen again. Yeah. So see here, Saml authentication request, service provider to IDP provider. And here is the authentication request by which the URL is Oasis name, TC Saml assertion, ID is there, who is the issuer, who is the name ID policy, request authentication. So this is a simple, we are not going to go into the detail of how this particular protocol works, but you need to take care about the architecture and how exactly the reason behind that is you must be aware of the architecture, because if you would like to find out the vulnerabilities, so what is the exact point where you are going to look at the things? So that is a question. So this is the request. So here look at the password protect transport here also is being given. And there is a response as well, embedded signature you can see. Just look at the way it is. I'm going to share this particular link with you shortly. If you get the time, go into the detail of how exactly the Saml works. Saml implements. We won't go into the detail of that, but you must be able to understand the architecture. So once again, let me explain the architecture over here. The architecture is, Saml is nothing but the security assertion markup language. So when you say it is a security assertion markup language, means what? you do have two things with you. One is the identity provider and one is the service provider. So when you have the identity provider, so identity provider is responsible, to authenticate the request, and the service provider is responsible to carry on that particular authentication and provide the token to the user. So at the first step, the user is going to ask, okay, so I do require, this is my identity, so I do require the authentication. So that particular request is captured by service provider, which is getting forwarded by 3 and the 4th step in the identity provider into the Saml request form. Saml response is going to be generated by identity provider, and at the 5th and the 6th step, this particular Saml response, which response is this? The authentication response of the Saml is being forwarded to the to the Saml ACS URL, and then only the ACS verifies the Saml response, and a user is logged into the Google application. Fine. So just take a note. I hope, Tanma, I've given the answer.
Yeah, ma'am. I got it.
Yeah.
Thank you, ma'am.
Fine. So we'll just have that particular thing to move ahead. So can you write it down, how exactly the SAML works?
Yeah, ma'am.
Yeah.
Ma'am, can I ask you one thing? Hello?
Yeah, go ahead.
So, ma'am, here basically the single sign-in, that I forgot the full form, SSO. That thing is basically the identity provider, right?
Yes.
Yeah.
Identity provider is supposed to authenticate.
Yeah, ma'am, got it. That I got it, but I just want to confirm once that SSO is the identity provider, no, not.
Yeah.
Yeah.
What is IDP? I didn't understand. The identity provider. What is that supposed to be?
Identity provider is supposed to take care about the authentication of the respective user, and the service provider is responsible to carry that authentication to the user. Okay, then?
Yes, ma'am.
Yeah.
Ma'am.
Yes, Ahmed.
Ma'am, there is one feature in Facebook that says login with email. Sometimes if you forget your Facebook password,
Yeah.
When you try multiple times, it says you want to log in with your email. Then
Yeah.
they link email. They send link to the email, and when you
Yes.
click on that link, you can automatically log into your Facebook.
Exactly.
How?
Exactly.
Yeah.
So
Is it,
that time the email is going to work as an identity provider, Ahmed. Okay, Ahmed. So here suppose the Google is your email. So in that case, your Gmail account is going to work as an identity provider. Fine?
Yeah. Okay.
Yeah.
Ma'am, again, so here the Google thing that because the user is just needed to enter the credential once single time. So there the open ID comes into the picture, right? The same ID can be connected
Please
with
do
everything.
not go with the OpenID and OAuth. We haven't discussed yet.
Okay, okay, okay.
Okay. Yeah.
Ma'am,
Yes, Avi.
ma'am, what is ACS?
What is
ACS.
access control list or access control system? What happened? Where exactly it is?
Ma'am, seventh step.
Yeah. Giving the access. ACS verifies the SAML response. Okay, access control system.
Ma'am,
Yeah, Avi, tell me.
ma'am, heterogeneity of system means the different types of users of the system,
Different infrastructure.
different
Different
infrastructure.
infrastructure. Yeah.
Okay.
Is it like this? Saml only happens for like popular applications, yeah.
Every application over the cloud, the SAML is doing that. Okay, so this is the industry standard right now, Dell.
Okay.
Ma'am, the example which Ahmed gave about that Google thing, that uses the single sign-on option, right? That particular thing. Okay.
What is assertion?
What is?
Assertion. I think the identity is the identity
Yeah,
provider
assertion.
creates
Yeah,
assertion.
so assertion means the positive response.
So how does it be created? How does the uh, identity provider create that? Like when the
Identity, if
client
the user is
accesses.
successfully authenticated, Dell, if the user is successfully authenticated, the identity provider is going to create the assertion that, okay, the user is being authenticated. Now we can move ahead with the further process.
Okay, so then it gives the assertion to the service provider.
Yes.
Okay. Yeah, I understand.
Yeah. Let me have the attendance right now. Attendance, please. 8.
Present, ma'am.
9.
Yes, ma'am.
15. 18. 19.
Present, ma'am.
20.
Ma'am, 20 present.
Yeah, 24.
Present,
Darren,
Present, ma'am.
29.
Yes, ma'am. 29.
36.
Present, ma'am.
37.
Present, ma'am.
38.
38 present, ma'am.
39. 40.
Present, ma'am. 40.
44. 47. 51.
Present, ma'am.
53.
53 present, ma'am.
7.
57 present, ma'am.
Palakjit, is everything is good at your end?
Yes, ma'am.
61, 64, 72,
Present, ma'am.
73,
Present, ma'am.
74, 80, 84,
Present, ma'am. 84.
86,
86 present.
87,
Present, ma'am.
89,
Present.
93, 96,
96 present, ma'am.
103, Krishnan, 104,
Yes, ma'am.
107, fine. So we'll meet tomorrow again. Not tomorrow. Tomorrow, do we have a class? Yeah. I think Wednesday we are not having.
Yeah, ma'am.
Yeah.
Yeah, ma'am. Tomorrow we have.
Yeah.